No prophecy dream this year, sadly to say. Yeah, tomorrow, if I have suddenly got a dream, I'll tell you guys about it. Okay, but guys, pay attention now. The first question for Wednesday most likely is going to be your motion time graphs, right? In terms of your motion time graphs, guys, the first question, your motion time graph, you have to be able to know the basic things, guys. The basic things for your graph is it's always going to be it will either be a distance time graph, or it will either be a velocity time graph, guys. If we talk about all these graphs, I've mentioned this over and over again. It doesn't matter if it's Hooke's law graph, volt versus current graph, or whatever. As long as graph, you always play with the what and the what. What? The gradient and the area. Very good. The gradient and also the area, right? For here, if I have a distance time graph, what does the gradient represent? Again, the basic stuff. Are you serious? It is definitely the speed, guys. Meaning to say, if I have positive gradient, it's positive speed, zero gradient, zero speed, and of course, negative gradient. Is there such thing as negative speed? It's negative speed. So what does the negative gradient mean? Going deceleration. And a few of you guys are. What are you doing there? Deceleration. When I say 考试, oh my God, Jesus! It is definitely going backwards, guys. And if you're lucky, you'll get straight line graphs, but most likely you will not be so lucky. You'll get curving graphs here. Until now, who don't know how to tell which one is increasing gradient, what is decreasing gradient? Which one? The first half is increasing gradient, or the second half is increasing gradient? This is increasing gradient. Increasing gradient means to say it is obviously increasing speed, right? This is when it is accelerating, guys. Only when the graph is curving in the distance time graph will you see that it is accelerating. Right? And this one here is obviously decreasing gradient, right? Which means to say it's decreasing speed, which is otherwise known as deceleration as well. Right? Guys, let me tell you, this deceleration is not the same as decreasing acceleration, which you're going to see later on, guys. I predict that the area represents nothing, by the way. So distance time graph, these are the only things you need to know of. Right, I predict tomorrow, right, on Wednesday, they will most likely ask you a velocity time graph instead. And if they ask you about velocity time graph, you need to know, obviously, the basic stuff first, right? The basic stuff is still going to be the gradient and the area. What does the gradient and the area represent? Acceleration and the distance traveled, right? Everyone should know this by now. So obviously same thing, positive gradient, positive acceleration, zero gradient, zero acceleration, and obviously negative gradient, negative acceleration, which is otherwise known as deceleration. Most likely they'll give you a curve graph, something like this or something like this here, right? You have to be able to mention that this increasing gradient is increasing acceleration, guys, and this one here is decreasing gradient, which is decreasing acceleration. My question is decreasing acceleration the same as deceleration? No, guys, you are increasing the speed slowly, but it is at a decreasing rate, right? So if they don't ask this curve graph, right, most likely they'll ask you instead the terminal velocity graph, guys. They say that, okay, explain in terms of forces how this ball reaches terminal velocity. Yeah, if you think back about terminal velocity, guys, terminal velocity is basically when the upward force is equal to your downward force. So you ask yourself, what is the upward force? This one for sure, air resistance, and the downward force will be, yeah, weight, right? Don't write gravity if they talk about force, because weight is a force, guys. Gravity is an acceleration. If they talk about force, you better write weight. Okay, you better write the upward force and the downward forces, right? So if you talk about this thing here, guys, they will most likely ask you to define the motion, or not define, like describe the motion of the ball as it reaches terminal velocity. You're supposed to say, pay attention, guys. You're supposed to say initially the only thing that acts upon it is gravity, right? So obviously it's going to accelerate downwards, right? As the speed, okay, internet connection unstable. Is everyone still here? Okay, whatever. As the ball accelerates downwards, obviously what's going to happen is the speed is going to start increase, right? When the speed increases, you need to know that the air resistance is directly proportional, meaning to say as the speed increases, your air resistance is going to increase as well, guys. And when your air resistance increases all the way until the upward force is equal to your downward force, right? This is when terminal velocity is reached. I think it will be much easier if you take a photographic memory of how the graph looks like, guys. You'll see that it is going to curve like this, guys. It's supposed to curve like this and then flatline eventually somewhere here, right? This part here is basically decreasing acceleration, guys, right? Because in order for it to reach terminal velocity, it must be zero acceleration, right? So you take a photographic memory of this, photo memory, whatever I just memorize. Just remember this graph, right? This graph is the important thing, guys. If you remember this graph, more or less, you can bullshit your way through this whole thing here.
Decrease speed and decrease acceleration. Yeah.
Decrease speed and deceleration. Okay, but please clarify any of these dumb questions that you don't know, right? Seriously, like you need to clarify all the dumb questions that you think you don't know or you know now, guys. It's very important. Yeah. So yeah, if you have any question, just clarify anything because you need to clarify everything right now, guys. Okay. So this one here you must know how to do this. Then everything else, if they talk about the motion one, most likely they'll ask you about the acceleration formula, the acceleration formula, which is but what happened? Where did my writing go? What? Zoom is laggy as hell, man. Seriously. Just when it is the most important day. Right.
It's not like normal.
Okay. Yeah, guys, this one you must know, guys, all these things here. So besides this, obviously you need to know the basic formulas, right? Like speed is equals to distance over time, velocity is displacement over time, and obviously acceleration is final velocity minus initial velocity over time. Guys, be very careful when you do this calculation here, guys. When they ask about acceleration, right? Sometimes they don't give you this value. You need to read between the lines and see the word rest, guys. If the thing is starting off resting initially, obviously your initial velocity is supposed to be zero. A lot of students, they always they're focusing on the numbers already, when they're doing calculation. They don't see all these words that are supposed to give you information. Make sure you highlight all the important information that you identify from the question before you do the calculation, because I can guarantee you, for sure you'll mess up one way or another if you don't write it down. It will be better if you can look directly at the information, right? You underline already, then you know what to do, guys. This one is very important. Okay. Then the second question will most likely, not most likely, this one is like a bit RNGesus already, guys. This one here, yeah, random number generating Jesus, right? Guys, if you talk about the second question, it could be literally anything. It could either be the momentum question. It could be the moment question. It could also be the energy question, guys, right? In terms of your momentum, a lot of you guys, you love to use the formula M1U1 plus M2U2 is equal to M1V1 plus M2V2, right? This is obviously the most common momentum formula, right, guys? But be very careful. Sometimes the question might just ask you for momentum only. If they are only asking you for momentum, you just need to use the mass times velocity formula. It's good enough already, right? And one more thing to highlight, if they talk about momentum question and they really do take the principle of application, principle of conservation of momentum, if this thing is a inelastic collision, how will the formula change? Yeah, inelastic is stick together, right? So if they stick together, how will the formula change, guys? Yeah, no more V1, no V2, guys. If it is inelastic collision, the formula will be M1U1 plus M2U2 is equals to M1 plus M2 V. Why? Because it's essentially M1V plus M2V. If they are in elastic collision, they will stick together and move together. There will no longer be two different speeds here. Instead, they will just become one speed. This is for inelastic collision. Inelastic collision here. Inelastic collision is going to be using this formula, guys. Be very careful with this one now. Then, of course, moments. Until now, I see a lot of you guys are still struggling with the chapter. Moments, guys. Moments is a very simple force times distance, guys. What's the condition for it to be a moment? The force and the distance must be perpendicular, and this distance is always from the force to the pivot, guys. Don't, you know, a lot of students, they like to use like, oh, if that's one force here and one force here, right? If let's say this is F1, they'll tell me that this is D1, guys. Bloody hell, the pivot is here. You can't dare to say this is D1, then it's GG. Don't record our, we record everything. All right, okay. Hey, don't tomorrow if on Wednesday you use this as your D1. Good luck, you idiot. Welcome again next year. I'll see you guys again. You idiot. This is your D1. Always remember it's force to the pivot. Force to the pivot. So the first thing you want to do is you want to identify where the pivot is. Only then you can use the formula, guys. If it's moments in equilibrium, what's the formula again? The word equation for moments in equilibrium. Yeah, the total anti-clockwise moment must be equals to your total clockwise moment, guys. This is the condition for it to be in equilibrium, guys. Define. They won't ask you this, but if they were to define, really? 2017. Principle of conservation of momentum basically states that the total momentum before and after the collision is conserved. You write it down in terms of the formula again. Right. Principle of conservation of momentum basically states that the total momentum before collision is conserved and it is equals to the total momentum after collision. You could say it like that, but I doubt they'll ask it again. But I could be wrong. Don't take my word for it. Right. So make sure you, if you have a hunch on anything, make sure you guys read up on it, guys. Then, of course, the energy chapter here. If they were to ask about the energy chapter, the most basic question, guys, will most likely be your principle of conservation of energy. If it's your principle of conservation of energy, what energy do they like to change in terms of the calculation? Yeah, it will always be gravitational potential energy to kinetic energy, guys. They love to ask this in terms of the energy chapter, and you must know that obviously mgh is equal to your half mv square, guys. In this calculation, I've mentioned this quite a lot of times already, guys. In this calculation here, you do not need the mass because they will cut off each other. A lot of students, they always ask me, hey teacher, I don't have the mass for this formula, how to do the calculation? You don't need the mass for this calculation because mathematically the m is going to cut itself off, right? And if the m is going to cut itself off, then you just virtually need the height to find the velocity only, guys. Most of the time it will be like one object falling from damn high, and then they're asking you from what velocity will it be? They'll say like maybe it's 100 meters here, right? And they'll ask you what's the final velocity here. This condition, this question, if you see the word no air resistance in red, if you identify like this question here is doing energy chapter, and then you see the word there is no air resistance involved, then it's most likely going to be this formula already. The potential energy equals to kinetic energy formula. Right, so you better be careful with this one. You don't need the mass component. Okay. Yeah. Then after that, the third question will most likely be a pressure question. Most likely be pressure. What's the two formulas for pressure again? Rho GH. Come on. F over A. Yeah, the P1. V1 is equal to P2, V2 is the Boyle's law formula. It's also a pressure formula. Guys, one thing I want to highlight in this formula here, your H is not the height from the ground to the thing. If let's say, for example, this is the tank, right? And they say that this is the point of interest. This is not the H. The pressure on this thing will not be dependent on the depth of water below it, guys. the pressure on this thing here will be dependent on the water molecules above it, guys. Right? So this is supposed to be your height that you're supposed to be using here, guys. You're supposed to be using this height here. A lot of students, they always do this mistake. I don't know why. You think about it, if this was the height, every time you jump into the sea, you die already, right? The height is so damn tall in the sea. All right. Then after that, most likely they'll ask you about the barometer and the manometer. So what does the barometer do again? What does the barometer do? It is used to measure atmospheric pressure, guys. Using to measure atmospheric pressure. The pressure due to the atmosphere will be from here to here. Always remember it's from liquid level to liquid level. And what's this gas, this like empty space here, what's it called? It's a vacuum, guys. Must be a vacuum. If it is not a vacuum, it's wrong. This whole thing will not work properly anymore already. And of course, if you talk about the manometer chapter, you'll have to always draw the arrows like I always told you guys in class, guys. For example, if let's say this is the height and this is the height here, right? You see that this pressure X. Let's just say if this is 5 cm, how much will the pressure X be? If you see these kind of questions, how do you do this? Atmospheric minus what? Minus 5. So it's 71, is it? Here is 71 cm Hg, is it? Then why anyone thinks that it's 71 here? Or you all still don't know how to do these kind of questions? How to do it? Wow, no one remembers how to do this. Bro, you're supposed to draw the arrows, guys. How many pressures are acting on the left hand side? There's only one here, right? How many pressures are acting on the right hand side? There's 2. Why 2? It's here and here, right? From here, you're supposed to be able to form the equation, guys. You're supposed to be able to form that pressure X is equals to the pressure of mercury plus the pressure of the atmosphere, which in this case here will be 5 plus your 76, which is your 81 cm Hg, guys. 81 looks more logical, right? If here is 81 and here is 76. Oh, it's very important. This one here you must know. Must know this one. Anyone here still do not know this?
But 5 isn't 5 just for
5 cm of mercury, man. You could use rho GH if they give you the density. If they give you the density here, then you can use rho GH to find here. But you'll have to find pascals. You need to find pressure in terms of pascals, the atmospheric pressure. Right. Usually it won't be like that, 76是 atmospheric pressure. 你要知道的这个 is like gravity 的 yeah 是 fixed 的，一定是76的 atmospheric pressure. Atmospheric pressure 这个76 yeah. What do you want to ask? All right. Then after that, the question 4 will most likely be your heat chapter question already. Your heat chapter question will either be a few only, either the conduction, convection, radiation, or your Q equals to MLF, Q equals to MC theta, all these kind of calculation question, or they will all put it into one. I predict this year maybe they'll ask you to calculate, find a way to do the calculation for specific heat capacity. How do I find specific capacity of an object? If I want to make an experiment to determine what the specific heat capacity is, what do I do? What information do I need? Do you need mass? Come on. Come on. Good. How do I find energy? Got energy meter or not? So if I don't have an energy meter, what else do I need to find the energy? You'll need the power. You'll need the time. Okay, you need the power and times. Guys, if they ask you to find the specific heat capacity, you're supposed to remember the formula Q equals to MC theta, guys, and your C would have been your Q over M theta. From here, this Q could be anything. It could either be power times time, or it could be VIT, guys. Guys, if let's say, right, they give you power, then obviously you can find just the power. But if they don't have the power, right, you'll have to find the voltage, the current, and the time, right? Because E is equals to VIT also, right? You have to remember this formula, you have to remember this formula to solve the question. From there, then obviously you know that your C needs these 5 components, right? If you can remember this formula here, then you can start bullshitting through. Say that, in order to calculate a specific capacity, I'll need to find how much voltage is supplied to the heat, how much current is supplied to the heater, how long was it supplied. I'll need to find the mass of the cylinder block, and I'll need to find the change in temperature. With all the formulas here, you're supposed to mention each one by one, then you'll be able to find it. What about convection current, guys? If they ask about convection current, how does convection current work again? Very good. Guys, if you talk about in terms of convection current, guys, let's just imagine today that, this is the fire that's burning the thing at the bottom, right? Then we just focus on 2, one particle here and then another colder particle here, right? Because obviously the hotter particles are closer to the thing, right? Guys, in terms of density, if you want to explain this, you're supposed to say that as this water particle is heated, obviously it will start to, before you talk about less dense, it will expand, guys, because heat expands and cold contracts, right? So when this thing expands, what happens is the volume actually increases, right? When the volume increases and the mass stays the same, according to the density formula, mass over volume, right? An increase in volume is going to decrease the density. If it decreases the density, obviously it will start to float upwards, right? As it starts floating upwards, probably not this way, probably this way, right? As it starts floating upwards, obviously this here will become an empty space, right? And it obviously won't become empty space, right? So what happens is the more dense particles, which are the cold particles, are going to sink to the bottom, because the density is higher here, guys. The density is higher here, so it will sink to the bottom. The less dense ones, because they are heated and expand, they will rise to the top. This is how convection current works, guys. You need to be able to answer this as well. Right, I think it might be this one this year. If not, it's going to be the Q equals to MC theta formula, guys. The graph, the straight line, the horizontal and straight line, horizontal and straight line one. Thermal capacity, you tell me. How much? Theta. C theta, yeah. Q equals to C the thermal capacity from theta. I told you, right? It is almost the same as this thing, right? Just that this is this and then this is this, right? It's just missing one mass component only, It's essentially the same thing, just missing one mass component here, right? Okay, so if they ask you this graph here, most likely they'll ask you what happens here. Why does it flatline here? Why does it flatline here again? Yeah, it is the bonds, guys. You're breaking the bonds to change it from one state to another, guys. So this is solid plus liquid, this is liquid plus gas, and this is obviously your gas part, right? You're supposed to mention that the energy is absorbed to break the bonds, changing them from one state to another. Okay. Now, if they ask you to define if they ask you to define the specific heat capacity, how do you define it again? Is this one here again, guys? You're using this formula again, the amount of energy needed to change 1 kg of a substance by 1 degree Celsius. It will be always revolving around the formulas and everything. 什么 ？K 什么？另外一个什么？对。Latent heat, Q equals to MLF and MLV. If it's LF and LV, how do I define it, guys? Yeah, same thing, guys. You rearrange it, and then it becomes like this, right? The amount of energy needed to change 1 kg of a substance from solid to liquid without any change in temperature. The key word is without any change in temperature. You must know how to define this. These are all your free marks, standard questions with all standard answers. Oh, one more thing I want to mention. In terms of this energy chapter. If they ask about this energy chapter, they'll say that your calculation is not correct to the real life scenario. Why? Yeah, your energy is always lost to the surrounding, guys. It's a very, very, very damn standard question with a very, very, very damn standard answer, guys. You must remember that the energy is lost to the surrounding, so it will never be the same as what you calculated in a real life scenario. Very important. Okay, everyone. You don't have to really copy. I record already. What else? Then after that it will be the wave chapter already, right, guys? If it's the wave chapter, they will ask you either it could be a lot of things on the wave chapter. They could either ask you reflection, refraction, diffraction. They could ask you the light rays, how will it behave? They could ask you the length, or they could ask you about electromagnetic wave or even sound, guys.
So sound.
Yeah. No. Okay, so let's imagine if they ask about diffraction question, they will only give you 2 scenarios only, guys. Which one has more diffraction? The one on the left has more diffraction. If there's more diffraction, guys, remember when you draw, guys, you're supposed to start at the opening here. You draw the start opening, and then the wavelength must be the same. When you draw it nicely. This wavelength must be the same here and here. Right? It must be the same because diffraction does not affect the wavelength, guys. Right? Whereas this one here, same thing. You're going to draw more squarish waves, but with the same wavelength also. Right? Condition is the wavelength is larger than the gap. And this one here, the gap is larger than the wavelength. If this is the case, then yeah, this one you must know how to draw. Must know. Must. Which one? Yeah, just like draw a little squarish shape here. Just make sure it's a bit more sharper, then you know that there's less diffraction. Don't like full circle on like this. Less diffraction, yes, it's the representation. Alternatively, you see online, some of them like to draw like this also. Right? They like to draw like this also. I mean, something like that. But just try to make it sharper, then you show that, I know that this is less diffraction. Then yeah, must minimum 3. And the wavelength, yes, the wavelength must be the same, No, it's according to the question. It's according to the question. If they ask you to draw 3, you draw 3. If they ask you to draw 5, you draw 5. If they don't say anything, minimum you must draw is 3. If they don't say anything, minimum you must draw is 3. Right. And then one more thing about this wave. Usually the students, they always cannot do this. If they talk about diffraction, guys, in light wave, they'll say that, okay, right now I have one object here. And it obviously goes through diffraction. Locate where the image is. Draw 2 light rays. How do I draw again? My eye is here. How do I draw this? What do I do? Where do I start? From the object or the eye? You always start from the object first. You want to draw like 2 V shapes here, right? And try to draw 2 V shapes here, right? Because ultimately, guys, you must know that the image is going to be something like this, right? It will be like one straight line here, one straight line here, then it's like going to dot, then it's dot, and then the light rays is actually traveling like this, right? You need to have this overall idea of the image in your head, then you can, like, from your head work it backwards in the real exam, guys. In the real exam, you must have this in your head. You always start off with where the object is first, guys. You always start off with where the object is. Draw 2 V-shaped lights, right? Draw 2 V-shaped lights, and then you draw. You want to open it. You want to open it up as it goes towards the eye, because here is where you close it down, guys. You guys got, I mean, this one here always comes out on. You must know. Yeah, you must draw a dotted line because this is for sure a virtual image, right? Yeah, anything it doesn't matter. Usually they'll say sketch only. It doesn't matter. But you need to know that it's like being inwards. This is the mental picture that you should have to draw, guys. But Okay, this is important now, guys. Most likely will come out. If not this, then it will be the lens chapter already. I highlighted this up. I'll say this again, guys. There will be two scenarios for the light rays one in the lens. If let's say they say that this is the lens and this is where the object is. If this is where the object is, your light rays are all supposed to hit the middle, which is the normal, right? And then it will all converge at the focal point, guys. They will all converge at one focal point here if the object is on the axis. But most of the time, the object is never on the axis. This is what you see more often. This is where your object is, right? If they draw this as your object, then obviously the light rays are going to be a bit different now, right? It will go straight to the normal, cut through the focal point, cut through the optical center. Wherever the two lines meet, this is where the image will be, okay? Exactly. Below, 这里. Oh, okay, good, very good question. If they ask you to draw three, right, you can draw the third one, which is cutting through the focal point here, right? And then one straight line all the way lah. It will be one straight line. It will like cut through the focal point here. Then after it will be one straight line here. It's just the exact mirror image of the first one. But sometimes they say you cannot draw this one at the bottom. If you are asked to draw not the one at the bottom, you just simply draw one light ray that hits the normal, and then you like hit it back into here, then can already. Yeah, they'll ask you not to draw the one that cuts through the focal point. If let's say this is the focal point and this is the focal point, then if you don't want to cut through the focal point, you just draw one that hits the normal and draw one straight line down here already. Okay. Yeah. Then what else? And then in terms of the echo, guys, if they talk about echo, you bloody hell better know that the wave is traveling twice the distance. You know, right? For example, if they say that okay, this is like a ship here, right? There's a ship here, and then it's like sending echo location downwards. Guys, you need to know how the sound travels, right? It will go downwards, hit the bottom, and then it will travel back upwards, right? Meaning to say the distance actually goes down one time and twice, right? If this is the case, you need to know that the speed formula is double the distance over time, right? Right, because it moves double the distance in a normal scenario, guys. Okay, very important. If you talk about echo, make sure you divide it by 2 or multiply by 2. So if let's say they say these kind of questions, right, they'll give you information like, okay, the speed. They'll say that okay, the speed of this thing is like 300 meters per second, right? And from the start of the boat to when the boat receives back the signal, they'll say that, oh, the time taken would be like maybe 10 seconds, right? And they'll ask you, oh, what's the distance? What's the distance here, right? A lot of students, they'll straight away just do this, they'll do like speed equals to distance over time, and then distance is equals to speed times time. And then they'll say that, oh, it's going to be 300 multiplied by 10, and then they'll say that this is 3,000 meters. Is this correct? No, definitely not. This 3,000 is like here and then go back here. So obviously you need to divide it by 2 here, right? Meaning to say in reality, this thing here is only 1,500 meters. You understand? This is how the question will be like if you talk about echo. You need to know, you need to imagine like how the thing goes on, right? It doesn't necessarily have to be a ship. Sometimes you'll say like it's dolphin or a racket hitting the wall or a sound bouncing off the wall or something along these lines. You need to know this, guys. You need to know this. You need to divide it by 2 or multiply by 2. Yeah. Okay. Right. Then after that, what else? What else will they ask? Once they ask about the wave, most likely wave will be 2 questions. 2 questions, wave. Oh, one more thing. In terms of the wave, doesn't matter if it's reflection, refraction, or diffraction. What doesn't change again? Frequency never ever changes. If they ask you very common question, they'll say like, what happens to the frequency after reflection, diffraction, or refraction? Either one. If you see the word frequency, straight away you need to know that it doesn't change. Frequency never ever change. The frequency never ever. 3 times 10 to the power of 8. 那个 speed of light, bro. Yeah, speed of light 是 electromagnetic wave 嘛。 Frequency is how many oscillations per second? 100 hertz 和200 hertz 就是说1秒里面 what in 1 second I have 100 oscillation and in 1 second I have 200 oscillation. This is what the frequency means, bro. Transverse, yeah. Oh, good, very good. If they talk about wave, it could also ask about transverse wave and longitudinal waves. Transverse wave are vibration perpendicular to the propagation, and longitudinal waves are vibration parallel to the propagation. This one here you must know, guys. Must know. Transverse is a sound wave, Nani. Only sound and ultrasound is in the longitudinal wave, bro. This is the electrical signal already. Yeah. You know, when you talk into the microphone, then they convert sound energy to electrical energy, right? This is what they feed back into the machinery to display. You get what I mean? Yeah, every other thing, but sound is transverse. 什么？不要打，对吧 ？Anything but sound is transverse. 这个是parallel vibration parallel to the propagation. 这个的 vibration is perpendicular to the propagation. The speed of sound, wait guys. The speed of sound in either solid, liquid, or gas. You always remember the gas one first, right? How much is speed of sound in air? 300. Yeah, somewhere around 330 meters per second, right? Then this is 1,500, and this is above 3,000. You always remember multiply by 5 and then multiply by 10 roughly. Remember this, you need to know this when you do your calculation. 不要弄啊，很累啊，昨天喝了好久了，没有力打你们俩这样子。I'm actually so tired today, I tell you. Yeah, 昨天4点就醒，玩到12点多先，是追不回家那种。哇，俺说4点兄弟 duties 啊，我们就呀，姊妹更早2点3点他们就醒了。Okay, all right, pay attention now. These numbers you must know. And then one more number you must know, the audible frequency range. Wait, how much to how much? 20 to 20,000 hertz. Guys, this is the audible frequency range. These numbers all must know. All of it you must know. What else do you need from the wave chapter? Okay. Then after that. Yes, exactly. Okay. Good. Wait here. No perioding. Just remember which one is more dangerous in terms of the electromagnetic spectrum. Gamma is most dangerous. Why? The highest penetration power, right? If it's highest penetration power, will the wavelength be short or long? What the fuck? Who said long one? Idiot! This is short, this one is the long one, right? And because of this, we know that the velocity is all the same, right? Meaning to say the frequency is high or low here. This one is high, this one is low. Okay. Oh, this one is important. You all need to know this. Huh? Jian? What do you mean Jian? Yeah. This one? Frequency and wavelength. Oh. Only these two. Nothing else. They love to ask you guys this. They love to ask you this. Infrared, visible light, and ultraviolet. They would like to ask you what it is. Infrared is anything to do with heat, guys. Anything to do with heat. The sun is hot. Yeah. Because it can send short communication signals. Radio waves. Radio waves. Because infrared has to send information through the control, man. It's like sending information through the signal of the light. So there's another receiver that receives the. What did you say? It won't be red. You won't see it, but you can see it with your camera. 你拿这个 controller 给我，现在。The red color light that you see is just visible light, lah, bro. Ultraviolet light can see. This is the infrared light that you cannot see. You see, no matter how many times I press it, you will not see it. But if you turn on your camera, 你按你 camera 拍着这个头这边。Yeah, you see this or not? Give me your camera. Bullshit, 你死人头啊 ！Bullshit, idiot. Where is it? What the hell? This one doesn't use infrared. 这个肯定不用 infrared 的这个。I think this one might use microwave or radio waves. This one, because you see, I don't need to click on. I don't need to point to it on. If it's infrared, you need to point into it on, right? This might be radio waves. I think. Definitely. Yeah, I think this one is using radio. Wireless mouse. Okay. Hey. Sorry. Wow, it's getting hot in here. Wow, I'm sweating already. Sorry. Hi, man. Okay. Yeah. So, yeah, anything to do with heat is infrared, visible light is everything you see, and ultraviolet, if they ask, will most likely for the money detecting forgery. All right, it will detect forgery. Yeah, you detect forgery money. I remember not the UV light that you scan. Forge money. Okay, so these are the things that you know. Then gamma, cancer treatment, X-ray, bones, microwave is for telecommunication, and radio waves is obviously one-way communication. Telecommunication 電話的咯 satellite information they supply energy to it. They keep supplying energy to it through microwave. Yeah. Microwave radiation has to supply energy to the molecules and then increase the kinetic energy, which converts into heat. Theoretically, yes. Induction cooker 是用电的，他们是用电的。Yeah, it uses electrical energy into heat energy. Radio waves is for one-way communication, bro. Radio tower. You cannot hear them talk, right? You can only talk. You can only hear them talk. They won't be able to hear you talk, right? Yeah. Then after that, what else? Oh shit, there's questions here. Oh my god, I wasn't looking at the chat, guys. You have. Oh my god. Yes. That's why you guys should say something when the question. What is this? You have to memorize 76 is atmospheric pressure. Yes, Leanne, you have to memorize that 76 is atmospheric pressure. So what if they ask to calculate the rate of what? Oh, which y lambda bigger than x? This is the condition. This is the condition. This is the condition for it to what's it called? Go through more diffraction. This is the condition for more diffraction to occur. This is the condition for less diffraction to occur. X is the gap between here. This is your X. This is your X. Oh, yes. Okay. How to spell the last word? Which one is the last word? Good. Which one is the last word? Propagation. Yeah. Propagation. Yes. Okay. Yeah. Moving on away. Okay. Then next thing will be most likely your electrical circuits. Wow, I tell you the circuit chapter is going to be huge. It could literally be anything. It could literally be anything. There's no way to guess it. It will either be the most common ones. They'll definitely test your understanding on parallel and series circuits. They will also ask you about the charges. Okay, let's talk about the charges one first. Which one? Electron? The Q goes to IT and Q goes to anyone. Yeah, this one here is the basic charge formula, right? This is in coulombs, this is in amperes, this is in seconds, right? This one here is the same thing also. This is in coulombs, but this N, it stands for the number of electrons. Yeah, and this E is the charge of one single electron, which is 1.66 times 10 to the power of -90 coulombs. Fix yeah. The only reason why current can flow from positive to negative is because electrons is flowing in the opposite direction. It is the flow of electrons which gives rise to current. It's like when we move, there's friction, right? It's because of the movement that causes the friction. In this one here, it is the flow of electrons which causes the current to flow. So this is your friction. The diode blocks it. Not electron, it blocks current, but in a way, in a deeper way, yeah, you could say it blocks the electrons, right? Which was the graph one? Oh, okay, good, very good. They for sure ask one this question. For sure, they'll ask one. So let's say if this is V and I, this is like I and V. Say something like this. Which one is increasing resistance and which one is decreasing resistance? Increasing resistance. 那个为什么 What is it? Yeah, it is because guys, the voltage here increases more than your increase in current, guys. Your increase in current is less than your increase in voltage. According to your formula, your Ohm's law formula, V equals to IR, right? Then R is equal to VOI, right? If this thing increases more than this thing, then obviously your resistance is going to increase, right? Guys, you need to know that both these things are increasing, just that the voltage increases more than your current only. No. What? Say that again. The current is decreasing at the end. This one is increasing less, this one is increasing more. Okay, then this one is obviously decreasing resistance because your current, this time your current is increasing more than your voltage, right? Now obviously this one is decreasing. Yeah. So 还有什么 ohmic conductor is just basically ohmic conductors guys are basically constant resistance, right? This is what we call ohmic conductor, right? Constant resistance regardless of however voltage or however current, right? Non-ohmic conductor 就是这样子咯 non-ohmic conductor 的就是这些红色咯 non-ohmic means to say their resistance keeps changing on, guys. It changes on. The resistance changes means to say they are non-ohmic conductors, really. Example of an ohmic conductor is basically these copper wires here. Example of non-ohmic conductors are basically the filament lamps or your heater ovens, you know how your ovens work, right?
No.
Idiot. Your oven now is supposed to have these constant metals. You're supposed to have these constant metals here, guys. As the voltage, as the current flows through it, the resistance keeps increasing, which causes the temperature to increase. So this thing here is like a cycle, right? The temperature increase, which causes the resistance to increase, which will cause the temperature to increase. That's why our oven keeps building up heat as it goes on and on and on.
Increase power,
Increase or decrease? When temperature increases, will the resistance increase or decrease? Increase, for sure, right? For sure, it's increase, and it's a cycle. It keeps like repeating itself. Why? I read about this before. I can't remember why already. I read about this before. I don't think about it. It has to do with the fact that the wire is being heated up. When the wire is heated up, then the flow of electrons is not so much anymore. Yeah, the flow of electrons was harder when the temperature is higher. I can't remember exactly why, but they'll never ask you this. They'll never ask you this, but you need to know that the temperature increases, the resistance increases. What else?
So in the graph, you don't have
INR. INR. How would INR work? Like this. Nah, they won't ask INR. Where got such a weird combo one? They won't ask one. What else? Oh, the circuit symbols. You need to know. Variable resistor, thermistor, light dependent resistor.
Diode looks like. Your consumer no gives out. Really don't.
These are all the things you need to know. Potential divider, usually they'll ask in paper 2. Very good. Is to control how much voltage is flowing in a certain part of the circuit. Control how much voltage is flowing in a certain part of the circuit. Yeah, like this one now. These are the potential meters, guys. You're basically like you're dictating how much voltage is going to be wait, am I sharing screen? Yeah. Oi, shut up, right. This one here basically connecting how much of it, then you're like using how much resistance. The less you connect, the less resistance you're going to draw from this, and obviously you're going to draw less voltage. And the more you touch is basically like conducting more resistance here, and then you obviously draw more voltage as well. This thing here basically is just to control how much voltage is being supplied to this line of the circuit only. Okay, this line of the circuit, depending on where you touch this arrow here, this arrow, do you see it or not? Depending on where you touch it, it will draw different amounts of resistance, which will draw different amounts of voltage, because the higher resistor will draw more voltage, right? So let's say, for example, if I place it exactly at the middle, it means to say this is like half the resistance only, right? Half the resistance means to say I only draw half the voltage, which is 5. If I touch it much closer, from on the starting point, there's even less resistance, right? Even less resistance means to say there's even less voltage. If I touch it more further away from the initial starting point, it will be more resistance and thus draws more voltage. So this thing here is basically just something to control. Rheostat. Rheostat is variable resistor. Yeah. It's the same concept. Same concept as a rheostat. A variable resistor. A variable resistor is a rheostat.
So this potential becomes the constant type.
Yeah, same thing. Yeah, same thing. A variable resistor, almost same concept here also. But variable resistors, you control the resistance, and then you control resistance by how much, by allowing the current to flow in certain amounts of the part. Have you ever seen a variable resistor before?
Oh, yeah.
A real life variable resistor you never seen before. Why wouldn't you see it before? You should do it. Yeah. This is, I show them first. This is a variable resistor. Have you never seen this thing before? Oh, Vicky, have you seen this before or not? This thing is basically, this part here is the part where current is flowing. Imagine I connect, I draw it out here. Imagine I connect the current to flow in here. The current, right, will flow on these wires here. They'll flow on this wire and then they'll come up through here again, right? So obviously, if you slide this more towards the left, right, what's going to happen is, right, the current will flow through less amount of wire and thus it will have less resistance. And then if it flows towards the right here, if it flows towards the right here, if I slide it towards the right here, the current will have to flow through this amount of wire, then only will flow upwards here. Huh? Choose the, yeah, you can dictate how much resistance will be used by sliding it left and right. Yeah, if it's longer, then it will have more resistance. 这个是拿来 control the current 的。For example, 你知道那个 ballroom 啊，他们有个 like spin the knob and then the light will become brighter and darker, right? This is that thing but with a more sophisticated version So like if I want it to be darker, right, then I increase the resistance more If I increase the resistance more, there will be less current Less current means to say they will become dimmer. Then if I want the light to be brighter, right, I'll decrease the resistance. Yeah. So if I decrease the resistance, there's more current then it's gonna have brighter.
You ask also, look at the same. You need you know, like those.
It's a bit different though. Like when you turn the knob, it actually receives different signals. So actually tuning into the different frequencies for the car one. Will it be the same? I don't think it's the same. I think it's also, but don't take my word for it. But it won't be in your exam, so it's irrelevant. Okay. LED is basically light emitting diode. Light emitting diode, you just draw a diode, but with light, like something like this.
Wrong.
Light dependent resistor is arrows inwards one, right? Yeah, thermistor is the hockey stick. Remember or not? Thermistor. No, when that's what I mean, like here. Point out words also lah, where else?
Yeah.
What? Mirror reflection. Like this, you draw it like this. And you're retarded lah. Why would you draw it like this? This one point like this, is it? This one then can lah. It doesn't matter about this one. Huh? Come on. 他不会叫你画 potential divider。我画咯，不是画这样子嘛好吗？I already showed you right just now here. Huh? 對對對，我就搞咗，再嚟先。要玩出去玩，沒有呢個啊 ？Which one? This one? This one? Down. This is battery ah, wait. Bloody hell, this is a heater, bro.
Heater. What?
Paper six always comes out one, this one. It's in your book already.
Yeah. 6 notes.
Sorry. Say, what was the question again? Function of potential divider is to control how much voltage is flowing in a certain circuit. What? Oh, good question. Don't write that. You must write gravitational potential energy out. Don't just write potential energy out. Like for example, they say that what energy does this convert into? If you write potential energy, you lose your mark. You must write gravitational potential energy. GPE. No, I don't recommend it. Gravitational potential energy. Gravitational potential energy is better. Okay. What else? What else? What else? The wire resistance one. Yeah. Hey, I know a lot of you guys don't know how to do this one. It's yes. Huh? They actually have one more symbol here. They have the resistivity symbol here, but usually we ignore this because it is the same material. If it's the same material, it will have the same resistivity. So we usually ignore this. You only need to take into consideration the length and also the area of the wire. Area of the cross section of the wire, not the area of this thing here, not this one, no one. Yeah. Pi r. Yeah. Hey guys, if they say it's area, guys, in this question, you all know, right? If they give you these kind of questions here, if they say double the area, what's going to happen to the resistance? No, you idiots. Well, why for? Why for? What? Tell me why for? But I'm talking about area right now. Y by R square. Okay, I give you two scenarios. Everyone shut up and pay attention to this. This is very important, I tell you. Depending on whether you do this or not, you understand this or not? L is the length. Okay, two scenarios. Let's say right now I have one wire. Like this. So let's say this is length and this is area. Okay, let's just say this is 10 ohm right now. Right now I have another wire, triple the length. Triple the length, but half the area. How do I do? How many resistance is this? How much resistance is this wire? Can you show me your calculation to get 600? 10 ohm times 3 length and then times the area some more. Or how about one cat and one dog? When they marry, what will they get? Yeah, one cat dog. Hey, no one knows how much is the answer. 6.
15, 60, 50, 40, 50,
Hey, how much is this one? How much? Huh?
60.
几咯？这个 60 why 60?
Length is 3. Right. Area, 1 area, for 2 hours because we have.
Guys, you check. Very good, Tristan. You check the length first, guys. Compare this with this. If you triple the length and resistance, what's the relationship? Directly proportional, right? Meaning to say, just looking at this itself, the 10 ohm already multiplied by 3 become 30 ohm. Just the length itself. But when we compare the area of this into this, what's the condition? What's the relationship for length and area? This one is inversely, right? This one is inversely, right? If I halve, means to say my area becomes smaller, then shouldn't my resistance increase? If my resistance increase, how much will it increase? If this is by 2 divide, right? Then you times 2 again, your 30 ohm, you times 2 again, it will become 60 ohm. This thing here will be 60 ohm. And this is true if they give you area and area only. But most of the time, they will not give you area and area only. Instead, they will give you diameter, or they will give you either diameter or they will give you the radius. For example, let's say same scenario. It's times 2 because the area 变小了嘛, right? The area becomes smaller, right? If the area becomes smaller, means to say my resistance increases, right? If here is a divide by 2, right? Divide by 2, my resistance for sure increases 的嘛. Resistance increase 一定要乘2嘛. Yeah, 得罢了. Because if let's say this one is like 1/3, if it's 1/3 divided by 3, then here will multiply by 3 already. True. If it's like triple the area, that means to say here is times 3 already, right? Then it means to say here will become divide by 3 instead. They are inversely. Yeah, it's the balik one, is inversely one. Right? This is true only if it's area. Not area.
I don't know as well. Do you need?
Alright, do your calculation. Tell me what's the answer here. 10 乘2除2 is it? I'll sell the I should have just continued drinking until I die last night.
Hey.
40啊，做乜40咧？做乜咧？乘二是吧？Just 出去后面刀哪一个刀？现在插死我！帮我去那个 kitchen 那边插死我！现在 this one you dare to say times 2 啊？我很想死啊！现在。Okay, let me just ask you one question only. Your final answer is 20 or the length itself is 20 only? Final answer is 20. Okay, tell me, how do you get 20? How? Okay, bye, go ahead. Come here and do it. Show me your working.
等于 O area 嘛，10等于这个 area 嘛，我把这个乘2，
Okay, 我要问你啊。I want to ask you one thing. Everyone pay attention to this. When you go to school, right? Do they say A for apple or do they say R for apple? When you go to school last time. Jia Bao, remember R for apple. Then you tell me it. I just Anna. If not map let A for apple, obviously you don't know already, right? Never mind. Then I want to ask, right? When you cut this and this away, wouldn't this just be length over area at the end? And then which will be equal, I can see this is a man of maths and English, guys. I can tell you that. Yeah. Need to get some drops in that.
I saw.
Right? 5. No.
Shoot.
Okay, don't give me answers already. Oh, I'm scary. Don't. Okay. How much? What's your answer? Uh-huh. No, it's not right. It's not. Let me tell you how to do this again. Everyone pay attention. I tell you. I tell you what, this question may just be the very question that dictates whether you get an A or a B. I tell you, because a lot of people don't know how to do this. Like literally, I think all my past year I've been teaching, I think like maybe 50 to 60% of people know how to do this only. If you can do this question, I can guarantee you you're higher in the threshold already. We look at it one by one first. Just looking at the length itself, how will the resistance change? 乘2了，这里你都讲乘2了已经变20 ohm 了Not taking into consideration the radius yet, it's already 20 ohm. So 20 as the final answer is no way in hell already, right? Okay, that's the first thing. Just the length itself already 20 ohm. Right now we look at the radius. The radius here to here. When you double up the radius, what happens to the area? By how much? Increase by how much? Why 4 times? This one is pi r square, right? This one is pi. What? This is 2 pi r square, right? When I double up the area, you see that this one becomes 4 pi r square. It actually quadruples up. When I double up the radius here, it causes my area to quadruple up. Do you see this or not? So when my area times 4, how much will my how much will my so it's 5. Huh? You say 5?
You say 5.
Sorry, 这个是我的错，因为I was confused by a lot of random answers that I cannot comprehend already. I also want to know who's the one drinking here. Right, this is 5. This is going to be 5 ohms, right, guys? Simply because when your radius or diameter doubles up, it doesn't matter if it's double up or triple up, right? There's a square component here, which will make it worse, right? That means to say, if let's say the question changed a little bit, guys. If the question is change it a little bit to like r to 3r, how? If let's say it becomes from r to 3r, it will become 9 times here. It will become 9 pi r. Means to say it will times the area will times 9. Area times 9 means to say on top here you need to divide by 9 as well. Half r 这边变成like 1/2r. If it's 1/2r, then how? Do your mathematics again, 1/4. So when you half the radius, your area drops by 4 times. It's different. Yes. A and R also is a bit different. Okay, Howard. Hey, everyone. This is like the last 2 days already. You better get this concept out. If you don't, then may the distribution gods be with you. Huh? Yeah, for sure. Means to say if you double down the radius, your area will quadruple down. When you double down your radius, your area will quadruple down. Okay. What else? What else do you need to know? Logic gate 不用啦, it's so simple, just follow the graph only. Okay. Where? Oh, why? Who knows? It doesn't matter. Okay. Any other questions? Area going down will quadruple what? Right here. Okay, one more question. One more question to check. To see how guys. I want to receive a message on Wednesday and say, teacher, thank you. I was a fool last time, but now when I calculated, I know I'm gonna get an A already. One more. Okay, so let's say this is Okay, give me an answer. Oh shit, wait. Let's make it easier. Hello. How much? Do your mathematics. Do your mathematics. Tell me the answer.
So what?
7.5. 37.5.哦，哪一个对，哪一个错？我不知道。
这个是 D bro。哦 ，S is 30的，这是30的，不是 D bro。
diameter。
D。是。
The high D。
就是拍 D 啊。
D。
D
Pi R square is the same as pi D 咩？啊？
哦。我定了一下，
It's not the same.
7.5. So
Confirm? How about here? 30. Why is times 2 one at the end? Half diameter, the resistance will half also. Is it?
no.
We try to okay, we're working right with one diameter that's 5 cm and another diameter that is 2.5 cm. What's the difference in the area?
7.5.
Or maybe, I don't know. Let me check. Cho working hand.
心动吧。
给我 calculator 一下。给我 calculator。
反正是240给18。
18啊！你刚才跟我讲18啊。Anything below 20 is wrong. Anything below 40 is wrong. Yeah, it is 60. 几个呀？
我翻译的话还有这是我们
另外哪色啊？我也行。He's actually correct. What he said was actually correct. Half D is half the diameter. 1/4 Let me tell you, pay attention, everyone. Everyone, listen up. This is the trick to this question here. The diameter and radius, right? Actually, they're the same thing. You need to know what their relationship is. If I halve a diameter, my area is actually going to decrease by a quadruple as well, guys. When I halve my diameter, my area will decrease by 4, by a multiple of 4. Okay, you can do this with your calculation. Go home and have a look at the numbers, right? If let's say this is like 10 cm and then like another one which is like 5 cm, You check and see what's the relationship in terms of the area. In terms of the area, you'll see that it's also the same thing on. If let's say this was 40 meters square, this one will for sure be 10 meters square, because it will also decrease. It will also decrease by 4 as well. So it doesn't matter if your area, your radius or your diameter decreases or increases, they are the same. If your diameter decreased by half, your area drops by a 4. If your diameter increases by 2, your area multiplies by 4 as well. Okay. All right, so in this scenario here, you're supposed to actually do this, you're supposed to compare this and this first, which you will get is basically going to be 10 divided by 2 times 3, which is going to be your 15 ohms, right? From the length itself is already becoming 14 ohms already. Then your diameter half down, right? If you half down your diameter, guys, your area divides by 4 some more. If your area drops by 4, it means to say you need to multiply 4 here, which is going to give you 60 ohms at the end of the day. Yeah, so you have to actually look and see. 不可以的啊。你不要回啊，拜拜。divide by 2 times 3 times 3. Because here to here is multiplied by 1.5, right? No. 是看这边的 ，OK? Yeah, the diameter divided by 2 your area. One more question, One more question. If you're wrong, you just skip lah when you see on Tuesday. $30分。
会啊。
我跟你讲啊，你没有 calculator 这题，你肯定做不到。没有，而且 and you need to do your working 什么 ？compare the length 啦 ，obviously。What's your answer? Okay. Wow.
What the fuck? Number right? It's not doing it.
Yeah, 5.9. Anyone that cannot get 5.9, you are wrong. Very good. True 三乘四 Yeah. 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 Now you have to compare this and this already. Four pi r squared and 9 pi r squared. Yeah, correct. 你看啊，你 after you compare these two things 啊，哦，9除10咯 ，so it's like 2.25啊，是2.25吗？这个对，你找到了吗？现在5.9 something。But they won't ask so hard lah. I think they won't ask so hard lah. You get it? 啊？你看那，你看那个 radius 有变大或者变小啦。如果你变小的话，那个绳变小了吗？如果变小了，就是一定高一点 resistance 就要成了。好像这个它 radius 变大吗？说大一点 resistance， 大一点的 area 的 resistance 加吗？所以要除哦。啊，对啊。Yeah, for sure. 明白了吗 ？Okay, anyone cannot do again 啊？But yeah, everyone can do this, right? I'll show you the working how you're supposed to do it. Very basic one in your head, right? Just first and foremost, you compare the length first long ammo. You compare the length. GG then. You compare here to here, right? It's basically multiplied by how much? It's multiplied by 4/3 lah, basically, right? You multiply by 4/3 ma, right? So this one here, the first thing is your 10 multiplied by 4/3 already, right? Which is some weird number 40/3 first lah. Then after that, you compare the area here and here, right? It's just basically pi r square and pi r square, right? Here to here is a multiple of how much? It's a multiple of 9/4, right? And I know for a fact that when my area increases, my resistance decreases, right? So you need to divide by 9/4, right? Then press this in your calculator and you're going to get 5.9. Something like that. Okay, everyone? Good. What else? What else do you need? What else do you need to know? Okay, what else do you need to know? For sure. Because it's in the graph, ma. Like, for example, here they say like, okay, find the energy needed for the ice at like maybe -10 degrees all the way until it becomes water at 50 degrees Celsius. Then this is the energy you need to find, this is the energy you need to find, and this is the energy you need to find. You have to plus them all together. All right. So this is how you link it. What else? Oh, let's talk a little bit about Fleming's left-hand rule and right-hand rule again. What do you do with Fleming's left-hand rule? Fleming's left-hand rule is used to find force, right? Usually it will be an AC or DC generator. It will be a
DC.
What? It will be DC, bro. Bro, you're looking for the force generated by the current, right? This is DC, right? Then your Fleming's right-hand rule is the one that is looking for current. Then this is for sure AC already, right? Very, very important. Make sure you read the question. And then don't go Bollywood dancing on Wednesday. I tell you, you point one finger at a time. Always point the magnetic finger first. For sure gotten. Then only you open up either one of these two and open up the rest. 明白嗎？咁多位。你看到你的 friend 在那邊跳 Bollywood 那時候，你就then you confuse them. They're like, am I wrong? Then you start to see they use the other hand already. Then they are wrong. What? Oh. Split ring, and which one is a split ring? Which one is a split ring? This is split ring, and it's split ring, right? What's the function of a split ring again? I don't want to. Allow the coil to continuously spin in one direction. Continuous. Shit, how do I spell continuously? N-O-U-O. U. Is it spell O-U-O? O-U-O. Hey, B for apple time. Yeah. Okay, yeah, continuously. Okay. Yeah, what else? What else do you need? What else do you need? For sure, they will ask about half-life on guys. Last part, I tell you the most common mistake that the students always do when they talk about this half-life here is that they forget to plus it back, guys. Imagine, hey, pay attention. This is the kind of question they'll give you. Let's say, for example, they say that without anything, there's a table. The question will be somewhere along these lines, and there is a detector here. Without anything, the detector reads 30 counts per minute. The first question to ask you is, where did this 30 counts per minute? Where is the source of background radiation? Yeah, the sources are, you always write the 4. Then after they say that right now with this new thing here, this new radioactive stuff here, the detector reads 300 counts per minute. Okay, let's say they say that the half-life they said that the half-life is 3 years. Tell me what the detector will read 9 years later. How much will the detector read? 300除2除2 is it? Hey, everyone do this, tell me the answer. Now. Yeah, I think you're right. I think it's right. Huh? Bad. Ben? Guys, listen up. If you see this question on Wednesday, guys, the most common mistake is the students straight away they'll take 300 divide by 2, then they'll tell me it's 150, then divide by 2 again, then divide by 2 again, and it's wrong already, whatever. This one is wrong already. You need to minus off the background radiation first, meaning to say, 30. So meaning to say it's like 300 minus 30, which will give you 270. This 270 will go through the decay, which is going to be 135, which is going to be like 62.5 and then 31.5. Then this is not the final answer. A lot of students is stuck here already. Then after you plus back 30 here, which means to say at the end of the day, this thing is going to reach 61.35. It's 67. It's 67 already, 67.5, sorry. Yeah, sorry, you're correct already. Then you plus back 30. Huh? You have to add back the 30 because this detector will not filter the background radiation. It will read like this all the way. So it'll read this thing, it'll read the background radiation, then it'll read it back here. You have the plus and minus also. You have the minus and plus also if they give you the graph. Yeah. So if they say about the graph, right, it will be something like this one. They'll say like, okay, right now this is the graph, right? Then they'll say that the background radiation is somewhere around like 30, and then they'll say like, okay, right now this graph is like this. Then they'll say like, okay, maybe it starts off with 100 lah, not 100. I'll do it so. Maybe like I don't know, 300 lah, right? Then I'll say that, oh, after certain time it will be this, certain time it will be this, and then certain time it will be this lah, right? Let's just say lah from here. Let's just say it's like 100. Oh shit, not 150. Like 200 and 300, right? 150 here, right? If they give you a graph like this, you need to first minus off. So it's 300 minus 30, which will give you 270. This 270, you need to divide it by 2, which will become 135. This 135, a lot of students, they'll straight away find, oh, 135 find here. Oh, this is the time to find the half-life. It's wrong already, guys. You should not do it because this 135 is just the radiation count from the source, but the detector will yet again read back your background radiation. So you need to 165. Then only you find, oh, 165 is somewhere here. Here's 165, right? Then you dot, then you find the time here. This is the time. This is the half-life. You get what I mean? You must minus, then you must plus it back because the detector will not filter. No, it'll be different every time. Oh, one more thing, I was talking about background radiation. If let's say, right, they give you a graph, like the background radiation from here becomes like 30, becomes 29, becomes 27, then 32, then 31, right? You have to take all, you have to find the mean of this. So you have to, yeah, you have to plus it all, then divide by the certain amount. Yeah, divide by 5 lah. Yeah, you plus them all together, then after you divide it by 5 lah. Okay, you're supposed to divide by 5, plus them all together. What period? Why? What are you asking? So 1 over F V. Yeah, you're talking about V equals to F lambda, right? Sometimes they'll give you the period instead. If let's say they give you a period is 10 seconds, right? Then your frequency is 1 over P which is 1 over 10. Then you sub this into this here. Period 就是 time 来的嘛。Frequency is 1 over period and 1 over time is the same thing. They are both in seconds. Okay. What else? What else do you need to know? What else do you need to know? Yeah, I think that's basically everything you need to know already. Huh? Oh yeah, calibration. If you know about calibration, you better know where the fixed points are. Where are the 2 fixed points? 0 and 100 are the fixed points. What else? Good. Okay, let's talk about thermocouple since we're on this topic. Expansion of liquid is thermometer. Expansion of solid is thermocouple. Expansion of gas could be used to measure temperature also, but that will be a gas meter. Yeah, because if you think about it, the hotter it gets, the more it expands, right? If it expands more, then there's going to be more pressure. That means to say by reading how much the pressure increases from 0 to 100, I can calibrate how much each Pascal represents in terms of temperature. Yeah, linearity, all those. Yeah. What? Work done. Huh? Work done. Yeah, they must be parallel to each other. Work done and force. Force and distance must be parallel. Moments is perpendicular. Oh, you're talking about the NOR and then another NOR, is it? This one would be back the OR. You mean like the one I gave you in your notes? What are you talking about?
Something not not same game, different games.
Oh, I know already. But it won't be so hard lah, for sure. Yeah, ABC will come out like this. If you are doing this, then you just label each and every one first law, A, B, C, D, right? If it's A, B, C, D, the combination is always the same one, ma. For you. Just a symbol for me to write down the inputs. So, yeah, your inputs will always be. What the fuck? Huh? It's the same here, what? This is F, ma. Then this will be F also. It's from here, coming from here. So if you see this kind of question, you do it one by one, lah, right? You see AB or AB is what? OR gate. Oh, sorry, NOR gate, right? NOR gate is basically 1 0 0 0, right? Depending on what it is, lah. Yeah, this F here. It's same, it's the same. Right, then H will be what? H is from E and F, what? So it's yi ling ling lah, right? Then your H is basically the reverse, right? So it's 0 1 1 0. Then after that, finally you want to get your Q already, right? Your Q is basically H and F, right? So you see lor, and gate, right? By right, I make it a Q prime first, so it's AND gate. Wait, 0 0 0 0. So the Q prime is 1 1 1. No, yeah. Oh shit, I'm looking at the wrong one. Yeah, H and F. Sorry, I'm supposed to look at H and F here. By right, it's supposed to be 0. No, it's 0 0 0. If it's an AND gate, I'm H priming it, right? Remember or not? Then only I would give the final one now, which is still 1 1 1 now. Ah, yeah. Say that. Shit, where did it go? Yeah. This one, right? NOR, right? NOR means it's E, what? By right, it's supposed to be 0 1 1 1, right? If it's an OR, then it's 1 0 0 0 lah, right? And after that, F is from the AND gate, right? AND gate is 0 0 0 1, right? Then after that, H, right? H is from where? E and F, what? E and F in the OR gate, ma. So 1 0 0 1. Because it's an OR gate, right? This one. Then after that, I'm looking for my H. H is basically just a NOT gate, right? Reverse everything. 1 becomes 0, 0 become 1. All right. Then after that, finally, I've reached Q already. But I see that this is a NAND gate. So I make a Q prime first. I imagine it's an AND gate first. 0 0 0 0 1 0 0 1 0 and 1 0 0. Then I just reverse everything. I become 1 1 1. 明白嘛？咁多位 logic gate is for very, very detailed conditions for it to switch on or off. So these logic gates are basically like receiving current from different sensors, and then they're sending signals like for specific conditions. It could be more specific, like, okay, today, if it is at night time, and then it is raining, and then the wind conditions is more than 50%, then I would sound an alarm. It's like that. It's a very specific conditions. So like each and all of these logic gates will be fed into a different sensor, and then they will feed back different information out on. It's very specific conditions. But you don't need to know this. Actually removing the syllabus already next year. Oh, sorry, this year. This year they remove already. But this year, the year 10, year 11 still have it. It will come out. It will come out. Okay. Yeah, what else? What else do you want to talk about? What else? Huh? Newton's law, 不会问. The 3 laws are, bro. First thing you learn. What else? What else do you guys want to know? What else are you guys not so good at? Huh? What else? Rectification. Oh. Yeah, the diode. Now it's that long, I don't. Oh, they removed it already. What?
Eden, I thought. Hey, really?
What? What?
What?
Oh, is this one, I think? Yeah. Guys, rectification is basically converting AC current into DC current, guys. This is what rectification is. You see, this last one here is due to capacitors. They are basically storing and releasing charges slowly, but this has been removed. So you only need to know these two only. You only need to know these two only. Because most electrical components, electrical circuits, they use DC power supply. Like for example, this thing here, it's taking AC, converting it into DC through the transformer and the diodes and everything. Okay, then full wave rectification, just basically like both wave also they make it positive already. But hey, if you don't want to remember anything, you remember that for full wave rectification, 1 and 4 diode will point in the same direction, and 2 and 3 diode will point in the same direction. You remember the pattern if you don't remember the thing. Yeah, as long as they're opposite, they should point. Yeah, they'll all be positive at the end of the day. The flow of current. Yeah, the flow will be something like this. Be like this, like this, like this, then like this, like this, like this, this for the first one. And the second one will be like this, like this, like this, this.
Is
alternating current bro. 什么？这个 rectified current 对 in short, you just rectify is like positive and negative all become positive. Most likely paper 2. Paper 4 they will ask also one, but they won't ask you to draw. I've never seen them draw before unless you're lucky this year. Unless you're lucky this year, you know. Hang okay. 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 Yeah. Okay. Lane, anything else? Anything else you all want to talk about? Yeah. Hmm. Okay. Okay, let me ask. Hey guys, anyone online has any specific topic that you want to talk about? Oh, thermocouple. Okay, good. Let's talk about thermocouple one last time before you guys go for an exam. Hey, if it's a thermocouple, guys, first and foremost, what's a thermocouple made of again? What meter is this? 不可以. Why cannot be voltmeter? Yeah, because voltmeter won't be able to detect the small change in the current or voltage. Yeah. Yeah, mini voltmeter plus milli ammeter 掺在一起. Just think about it that way, okay? So this one here will be metal X. Let's say this is iron. Will this be copper? Constant, iron, right? Then after that, it will be a hot junction here. There will be a cold junction here, right? Then there will be a different wire here, or whatever lah. It must be a different wire lah. Yeah. Then after that, usually you need to calibrate it, right? You calibrate it. What temperatures do you use again? 0 to 100 degrees Celsius. You put both wires in and then you detect how much current or voltage will be generated. Let's say, for example, it gives 0.1 ampere, right? If it's 0.1 ampere, that means to say every 100 degrees difference is a 0.1 ampere reading on the galvanometer, right? So if let's say I have something damn hot, I don't know damn hot, I don't know what it is, but definitely not you. Let's say I read 0.5 amperes here, how hot will the thing be? It'll be 500, right? If I want to measure something that is damn cold, let's say I want to measure something damn cold, I put back the hot junction to 100 degrees Celsius law, right? And I want to measure something damn cold, but I read 0.3 amperes here. How much will the cold junction be? Why? Yeah. Because this means that the difference from here to here is 300 degrees difference. Right, 300 degrees difference means to say it's negative 200 only. If they talk about thermocouple, they'll ask, what's the benefit? Why do I want to use something so complicated? Fast response, good. And wide temperature range. Basically, you can measure anywhere from negative 200 degrees Celsius to 1100 degrees Celsius. What? One coulomb? Yeah. Yeah. One coulomb is one charge, you know. Charge is charge. Charge is positive or negative charge. Coulomb is the units of charge. Wow. Say your words, I only know coulomb is the units of charge, and charge is positive or negative charge. But one coulomb is one charge. I find. It's one coulomb, one charge. A coulomb is one coulomb is equals to the amount of charge from a current. One coulomb is equals to the charge of. Nope, it's not. One coulomb is equals to the charge of 600 over protons. No, they won't. No, the metal doesn't always have to be iron. The end. It could be any metal. If let's say this one here, you don't want to be iron, let's say you wrote steel instead. And then this one is steel, right? Then this one cannot be iron, or it could be copper, or constant, anything but steel lah, basically, zinc or whatever lah. Just in short, these two wires must always be different only. The blue and the brown one must be different. Doesn't matter what, but they must be different. 差不多. And hot is no. Why will the hot always be the left, bro? It could be anything. It could be on any side. What? No, no, definitely not. They are not chemistry units. Okay, guys. Anyone else got any questions or not on this part here? Okay, guys, if you have no questions, I'm going to end class here today right now. You guys, hey, sharp boy. If you guys have any questions, come over tomorrow to clarify your questions. I repeat again, don't come over. Paper 6下个月，下个月啊，现在啊，下个星期搞 Paper 6。I thought it was in November. Ah, Paper 2 啊。Oh, come on Monday. Yeah, come on Monday. We'll talk about Paper 6. No. Come on Monday. You better come and you better have done some Paper 6. I tell you, if you come and you're like expecting from 0 to 100, you're already dead. You are already dead. Okay, guys, that'll be it for today, guys. I'll see you all for those who are coming to. Yeah, Paper 4 is on Wednesday. Okay. Everyone, good luck for your Wednesday paper. Come on. 他写了，你要什么约的 ？All right. Okay.